Assalamualaikum and good day to you all. My name is Siti Karmila and here I would like to present my final year project 1 with title of Optimization of Material Transportation System in a Manufacturing Facility, which supervised by Prof. Madya Dr. Muhammad Hafidz Fazli bin Mat Fauadi. Here is the slide for introduction to material transportation. Material transportation system is commonly used in manufacturing facility. It is important to ensure the transportation system is operating efficiently so that manufacturing performance could be increased. This study utilized a simulation approach to evaluate the efficiency of the system. There are few types of material transportation in manufacturing facility. The example of material transportation is forklift, automated guided vehicle, conveyor, and robot handling system. Optimizing the material transportation has lots of benefit, which is cost reduction, improve the efficiency of the production, and increase the productivity capacity in manufacturing facility. There are three optimization methods as shown in the tree diagram. The method is simulation, mathematical, and approximate algorithm. In this project, it will mainly focus on the simulation method instead of mathematical and approximate algorithm. Simulation provides an efficient, cost-saving, and environmental-friendly way to develop projects, as they remain in a virtual environment until it is built in the real world. There are three problem statements for this project, which is current transportation system does not fully optimize in transporting materials. Secondly, ineffective transport planning could affect the whole process in a warehouse. And lastly, the traffic congestion in the logistic and transportation system. If there is a problem, that will be aim or the objective to encounter the problem. So the objective for this project would be to identify problems and solve for current material transportation system which does not fully optimize in manufacturing facility. Secondly, to increase the productivity of material transportation system in manufacturing facility. Lastly, to evaluate the achievement of the proposed techniques. The scope for this project will mainly focus on simulation of material transportation system for manufacturing facility, research on automated guided vehicles only, and analogic software used to simulate the structure. For this slide, it's about literature review, which is selected case. For the first case, use the dispatching rule method, which is linear programming along with simulation software of UTeM plant. The aim of this case to determine the number of vehicles in AGV and to increase the efficiency process, which quite similar with my project. Figure 1 defined as the number of AGV more than 3, the processing of the CNC become more satisfied. The second case use mathematical method and FlexSim software. The objective is calculating the optimal number of AGVs. The other objective is develop system in chosen simulation tool. The table shows the result for this case with different quantity of AGVs. The results state that the most efficient would be 3 AGVs. It has the lowest number of AGV that able to achieve the proper performance. The third case has an objective to increase productivity by choosing the appropriate AGV to handle transportation. There are two results, which is productivity and make span. Figure 2 is for productivity result and figure 3 is make span result, which show the optimal value of AGV. The fourth case study on the efficiency evaluation of AGV fleet sizing and operations. When the number of AGVs were increased, average ship service time, utilization rate, and the operating cost of quick cranes were decreased, while the average utilization rate and operating cost of AGVs were increased. The last case has an aim of methodology for estimation the minimum numbers of AGVs required. The results state that the table search present better result rather than the shortest job first. Here is the overall flowchart for this project. On the left side is the process need to be completed on FYP1, while the right side need to accomplish on FYP2. Objective 1 and 2 can be achieved when the simulation approach with parameters completed, while the objective 3 achieved when the result experiment conduct is accepted. This is the details for method in accomplishing this project. The step that should be done is dispatching rule, simulation approach, performance measurement, and preliminary result. This table shows the comparison of selected dispatching rule, which is first in, first out, last in, first out, and shortest processing time. The first column shows the definition of the rules, while the second and third column shown on the advantage of each dispatching rules. The dispatching rule that has been chosen for this project is first in, first out, or we could call as FIFO. FIFO for warehouse is the most popular method for organizing the warehouse space. The FIFO method introduces efficiency by limiting material handling and minimizing the overall usage of warehouse space. It also the simplest method and follows the natural flow of inventory. This is the flowchart that will be done during simulation approach from the design AGV system till the result is accepted. On this approach, there will be a few different parameters required for conducting this project. There are two performance parameters, which is throughput time and cycle time. Throughput time is total elapsed time from start to the finish of a job being processed at one or work centers, while the cycle time is the maximum time allowed for work on a unit at each station. For table 4 is about the average throughput for each experiment. The number of experiments conducted will be listed on the experiment column, and then the average throughput will be calculated. Then on table 5, the average throughput that has been calculated before will be inserted into this table. Then the cycle time could be obtained by using the formula cycle time. This slide on my expected result for this project. As the cycle time and throughput has been obtained, the Pareto diagram could be developed. Then it able to determine which number of AGV is the most optimized. The graph 6 shows the example of Pareto diagram that will be produced after obtain the cycle time and throughput data. Somewhat, the end result will look like this: the bar chart for the throughput and line graph for the cycle time. Here, I would like to conclude for this presentation. For this semester, I have done on formulate the research problem required for this project, then the study on previous research about optimizing the material transportation. Moreover, the data has been collected and analyzed for optimization of material transportation in manufacturing facility. My planning for next semester would be start to do the simulation approach for this project to determine the optimization of material transportation, include learn on how the analogic software would works. Finally, to test and analyze the result that has been obtained along with the documentation report. That's all from me for my final year project 1 presentation entitled Optimization of Material Transportation System in Manufacturing Facility. Thank you.